Okay, so yesterday we have solved linear differential equations of the form fd operating on y equal to 0, and we have seen that its solution is given by complementary function, and you know how to find the complementary function. Now I am taking up linear differential equation with constant coefficients, but right hand side is a function of x. In a state of 0 we have a function of x. Now, its solution is given by two things: complementary function plus particular integral. As I have shown you an example yesterday, where I have shown you how to find the complementary function as well as the particular integral for that particular question. In general, if x is any function, say e raised power ax, sine function, cos function, or a polynomial, or product of two functions, how to find the particular integral? Now, there are methods. Let me write down working rule for finding the particular integral. Pi. See, now case 1. First of all, let me tell you, you have fd operating on y equal x. Fd operating on y equal x. Then you can see that y is x upon fd. This y, this is not complete solution, as you have seen yesterday. This is not the complete solution. This in yesterday's question I have shown that this is not the complete solution. Complete solution is pi plus cf. But here y is x upon fd. This y is known as the particular integral. So particular integral is always x upon fd. Okay, but as you have seen, this is not the complete solution. We have to find both complementary function as well as particular integral. Now case 1, when capital X is of this form, e to the power ax, then what is pi? Then particular integral is x upon fd, as has been seen, x upon fd, which is equal to e to the power ax upon fd, as in this case our x is x, e to the power ax, and this is nothing but e to the power ax upon f of a. Means that I am replacing d by a, but the condition is that f of a is not equal to 0. So if x is of this form, e to the power ax, then particular integral is e to the power ax upon fd, which is e to the power ax upon fa, but then denominator should not be 0. If fa is 0, however, if fa is 0, what will happen? Then we use the formula e to the power ax upon d minus a raised power r is equal to x raised power r by factorial r e to the power ax. You see, when you have a raised power ax upon fd, what you do? You replace d by a. You see, if I replace d by a, this is e to the power ax upon a minus a, which is 0, right? So in this case, if the denominator is 0, I have a case of failure. This is known as case of failure. I have to use this formula. Where does this formula came from? I will be showing this. I will be explaining this everything. Okay. So first case is, then if x is e to the power ax, then I have replaced d by a. I have to replace d by a in pi. And if f of a is 0, then I have to use this formula. I will be explaining it later. Case second. If x is equal to sine ax or cos ax, say instead of x you have sine or cos, then pi is equal to sine ax or cos ax upon fd square. Not fd, it is fd square. If it is fd, then we have to bring a d square there. Instead of d, I have to bring d square. How it is done, I will be showing that. But then if particular integrals, if it is sine, again, if it is sine, y is sine upon fd. If it is cos, cos upon fd. However, in sine and cos, instead of fd, we write fd square. I will be explaining you why this fd square, which is equal to, which is further equal to particular integral sine ax or cos ax. See, you have fd square. It is f of minus a square. Again, the condition is that f of minus a square is not equal to 0. This is the condition. But then it may happen that f of minus a square is 0. I have a case of failure. If f of minus a square is equal to 0, then sine ax upon d square plus a square is equal to, see, case of failure is means you have to replace d square by minus a square. Minus a square plus a square is 0. So if such is the case, then sine ax upon d square plus a square is minus x by 2a cos of ax. And if it is cos, cos ax upon d square plus a square is x by 2a sine of ax. As I have said, I will be explaining each step. Don't worry. This was case 1 and case 2. Now case 3 is that, fine, let me explain it again. If you have sine or cos, in the denominator you will have, instead of fd, you will be having fd square. If it is fd only, then we can convert it into fd square. Fd square is to be there. Now, for that, you have to replace d square by minus a square. If f of minus a square is not equal to 0, then there is no problem. But if f of minus a square is 0, then you have to use these formulas. Sine upon d square plus a square is minus x by 2a cos, and cos upon d square plus a square is x by 2a upon sine. I will be explaining it. Case 3. If x is a polynomial in x, then pi is equal to polynomial by fd, which is equal to polynomial by 1 plus minus some function of t. This is small fd, this is capital fd. What we are actually doing is that from this fd, we are taking the lowest degree term out of this fd. Taking lowest degree term away from fd, outside fd, I will get a factor of this type. 1 plus fd or 1 minus fd. This is being done by taking the lowest degree term outside of fd. Now, when I will get 1 plus minus fd, what is the next step? I take it to the numerator. Instead of denominator, I am keeping it in the numerator, raised power minus 1, and operate it on a polynomial because this is a differential operator. And to evaluate this, I use binomial theorem. See, 1 plus x, you know, 1 plus x is power minus 1. It is 1 minus x plus x square plus x cube plus so on, minus so on. 1 plus x minus plus minus and plus. 1 minus x is power minus 1. It is 1 plus x square plus x cube plus so on. I will be using these formulas, or if instead of 1 you will get 2 or 3 or 4, you know 1 plus x is power n. It is nc0. You know this formula. I don't have to tell each and everything to you. Okay, this is case 3. Now case 4 is that Case 4. If x is of the form e to the power ax into v, where v is a function of x, means you have two functions. Say e to the power ax into sine function, e to the power ax into cos function, e to the power ax into polynomial. We have discussed these three cases. Now how to find the particular integral? See, particular integral is e to the power ax, as it it is x upon fd. It is x is e to the power ax into v, product of two functions fd. This is nothing but you are taking e to the power ax out. What is the factor remains is f of d. Instead of d, you replace d by d plus a, and whatever the function is, it operates on v. This is the rule. E to the power x, you have product of two functions and you have fd. You are taking e to the power x out of this, and by taking e to the power ax out, you will be replacing d by d plus a, and whatever this d plus a will be, or 1 over d plus a be, you will operate it on another function. Say if it is sine, then you have to operate it on sine. You know what is the rule for finding the particular integral for sine. If it is cos, you know what is the how to find particular integral for such type of equations. If it's a polynomial, then you have to use binomial expansion. I'll be showing this why this is being done. Okay, you know these things. Let me explain you one by one, case 1, case 2, case 3. Why are we doing such things, and why are we writing particular integral in this form? See, this is quite easy now. When x is e to the power ax, what is differentiation of e to the power ax? Differentiation of e to the power ax is a e to the power ax. What is d square of e to the power ax? It is a square e to the power ax. What is d cube of e to the power ax? It is a cube e to the power ax, and so on. If I will add up these three, d cube plus d square plus d operating on e to the power ax, I will get a square plus a cube plus a square plus a e to the power ax. This is quite simple. So generally, if I will have fd operating on e to the power ax, I will get fa e to the power ax. So therefore, if I will divide these, e to the power ax upon fd is nothing but e to the power ax upon fa. This is the particular integral which I have told you, x upon fd. X upon fd, e to the power x upon fd is e to the power ax upon fa. You are always replacing d by a. You can see. When it is d here, it is a here. D square, a square. D cube, a cube. Whatever be the function. In case of e to the power ax, you have to replace d by a. Fine? If you have e to the power 2x, fd, this will be e to the power 2x, f of 2. E to the power minus 5x, f of d, e to the power minus 5x, f of minus 5. Clear? But I have said that e to the power f of a is not equal to 0. Now, if f of a is equal to 0, how do you find f of a is 0? You see, if you have e to the power ax and you have ft, how do you know f of a is 0? This is being done only, and this is possible only when you have a factor of this type, d minus a, right? E to the power ax upon d minus a, you have a case of failure. E to the power ax, d minus a whole square, you have a case of failure. D minus a whole cube, you have a case of failure. So case of failure is possible only when you have a factor of this type. Now let me suppose that I have a case of failure. Case of failure means f of a is 0. Let me suppose that first this one. I have particular integral e to the power ax upon d minus a. I am taking only d minus a, not square, not cube. I will be explaining on this and rest will follow. You see, this can be written as e to the power ax into 1. Does it matter? It doesn't matter. Now this type of equation, you have e to the power ax into 1 upon fd, right? You have seen that if you have e to the power ax into b fd, then this particular integral is e to the power ax out. You replace d by d plus a and operate on the rest of the function. Here it is 1 v. You see, by using rule 4, this is e to the power ax, replacing d by d plus a and operated on v. V is 1 here. This is e to the power ax into b upon fd. Rule is e to the power x is to be taken outside, then replace d by d plus a. I am doing that, d plus a minus a, and operating on v. This is it. This is the rule 4 which I have just quoted. Now a and a cancels out. This is e to the power ax 1 by d of 1. You see d, what is d? D is d by dx. So what is 1 by d? It is the integration. Now what is the integration of 1 by x? It's x. Fine. I can write it. It is x raised power 1 upon 0 factorial. Okay. I don't need that. Let me write it as x raised power 1 only, because I have got integration of 1 is x. Now let me suppose that you have square here. Instead of raised power 1 you have 2. This means you have square over here. Fine. Means a and a cancels, you have square over here. That means you have to integrate 1 by d square 1 twice. First time it will be x. Second time it will be x square by 2. Fine. So this will be x square by 2 or 2 factorial. Now if it is 3, if it is e to the power ax d minus a raised power 3, what is the method? I have to replace e to the power ax is to be taken outside. I have to replace d by d plus a minus a whole raised power 3 and operate on v. What is v? It is 1. So I have e to the power ax upon 1 upon d cube. So I have to integrate thrice. 1. First time its integration is x. Second time its integration is x square by 2. And third time x square by 2. Integration is x cube by 3. So this is 3 factorial. So this is e to the power ax x cube by 3 factorial. So in general, if you have e to the power ax upon d minus a raised power r, if you are generally e to the power ax d minus a raised power r, in case of failure you have to multiply by x raised power r by factorial r. E to the power ax will be there. X raised power r by factorial r. Forward, this is rule 1. When x is e to the power x, then you have to replace d by a. If you replace d by a and f of a is not equal to 0, then it's okay. But then if f of a is equal to 0, then you have to use this formula. I have explained this why we are multiplying by x square, x raised power r by r factorial. Now second one is sine and cos. I will show you sine or cos. If I will show sine, you have to cos yourself, and if I will show cos, let me show you up to particular integral of sine. Now you have f of d. Let me explain it like this. What is differentiation of sine? Ax. I want to find the particular integral of sine ax upon f of d square instead of d square. Why d square? I will be explaining. What is differentiation of sine of ax? It is a cos of ax. Fine. What is d square of sine of ax? It is a cos means minus sine, so minus a square sine of ax. What is d cube of sine of ax? It is minus derivative of sine is cos, a cube cos of ax. What is d4? sine of ax minus derivative of cos is minus sine, so minus minus plus a4 sine of ax. What is d5? Sine of ax. Now derivative of sine is cos, so a5 cos of ax. What is d6? Sine of ax. It is minus, derivative of cos is minus sine, so a6 sine of ax. Now see, and so on. You see what is here? It is d square, and what is here? It is minus a square. It is d4. d4 can be written as d square whole square, and this can be written as minus a square whole square sine. Fine. d4, instead of d4 it is d square whole square, but instead of a4 I have written minus a square whole square. Fine. Leave this d5. This is d square whole cube. d6, it is d square whole cube. I will write it as minus a square whole cube sine ax. What is important is that you have a function over here, you are getting this function over here. You have a function sine, you are getting sine. You have function sine, you are getting sine, but then at what value? You have d square here, you have d square, you are replacing d square by minus a square. You have d square over here or d4 over here, which is d square whole square, you are always replacing d square by minus a square. You have d6, which is d square whole cube, you are replacing d square by minus a square. So, if you want a function, if you have f of d square over here, sine of ax, you will get f of minus a square over here, sine of x. So if I will divide, I will get the particular integral which I have shown, that sine ax upon f of d square is equal to sine of ax upon f of minus a square. I am replacing d square by minus a square. Same is the case with cos. Instead of sine, if I will write cos, you will find d square is replaced by minus a square. Fine. But the condition is that f of minus a square is not equal to 0. If f of minus a square is equal to 0, then I have used some formula. Let me show you. I hope this is clear. Huh? Now, case of failure. You have sine ax upon d square plus a square. You know, for sine ax or cos ax, you have to replace, let me write both. Sine ax or cos x, you have to replace d square by minus a square. So minus a square plus a square, it will be 0. So what to do? See what to do. I will write it as e to the power iax. Let me consider e to the power iax upon d square plus a square. See, when you have first case, e to the power ax upon d, f of d, you are replacing d by a. So instead of a, you have iota a. If you will replace d square by iota a square, it will be minus a square, case of failure. So there is nothing to worry about. Okay, if it is sine over here, I will take the imaginary part of this. If it is cos over here, I will take the real part. Now let me not go to the real and imaginary part. This is of first case. It is e to the power ax upon f of d. What I have to do? I have to replace d by a. What I will do is that this is e to the power iax. This is d plus iota a into d minus iota a. Right? I have splitted it. D square minus iota square a square. What is that? D square plus a square. Now for this, let me suppose that this fraction is not there. D minus ia is not there. What is the rule for this function? E to the power iax upon d plus a. I have to replace d by iota a. So this will be 1 by 2 iota a e to the power a iota ax. But I have one more factor. What is that? D minus iota a. Fine. In the factor which is not vanishing, I am substituting. I am using rule 1. I am replacing d by iota a. I have 2 iota a. For the function which gets vanished, I am keeping it like this. And for that function, I have a case of failure. If you have e to the power ax upon f of a, there is a case of failure, what I have to do? I have to multiply by x raised to power r by r factorial. I have x raised to power 1 only. R is 1 here. So I have to multiply by e to the power iax multiply by x raised to power 1 by 1 factorial. Right? See, this is case of failure. E to the power iax upon d minus a raised to power 1. This is a case of failure. So its value will be e to the power iax multiplied by x raised to power r, which is 1 by factorial 1. That is what I have done. Now, this is x 2 iota a e to the power iax. It is cos ax plus iota sine ax. This is equal to x upon 2 iota a cos ax plus x upon 2a sine ax. Iota iota cancels out. This is 2 iota a over here. It is cos 2 iota a into iota. So it is 2a only. But this iota, it can be written as minus x by 2a cos of ax plus x by 2a sine of ax. I have used the formula that iota square is minus 1. You have this one. This one I have written as this. Minus 1 into iota square. It is plus 1 x by 2 iota a. Iota iota cancels out. What remains is minus x by 2a. This is what I have written. If you compare the real and imaginary parts now. If you have sine. See. E to the power iax. Cos ax plus I sine ax. So cos is the real part. If I will take the real part. Real part is cos ax upon d square plus a square. Now what is the real part? This is the real. This is iota here. Minus iota. This is 1 by 2. Let me explain it again. Why does minus iota comes here? Why is minus iota over here? This is 1 by 2 iota. I have written it as minus iota square. Iota iota cancels out. This is minus iota x by 2a. Minus iota x by 2a. Okay. Now I am taking the real part. Cos d. What is the real part? X by 2a sine ax. And what is the imaginary part? Sine. Sine ax upon d square plus a square. It is minus x by 2a cos ax. This is the formula which I have written there, which I have used and I will be using in future also. Fine. I hope this was okay. Now third one. A polynomial. I don't have to explain anything regarding polynomial. Now fourth one is important. If you have e to the power ax into v and fd, then what is being done? It is e raised to power ax replacing d by d plus a and operating on rest of the function, which is v. You see why it is being done. What is differentiation of e to the power ax into v? These are two functions. So product rule. It is dv e to the power ax as it is. Then e to the power ax v as it is, derivative of e to the power ax, it is a e to the power ax. Is it okay? You have two functions. Keep e to the power ax as it is. Differentiation of v with respect to x is dv. Then keep v as it is. Derivative of e to the power ax is a e to the power ax. Now this is nothing but e to the power ax. Okay. D plus a operating on v. Is it okay? You have taken e to the power ax out. This one. And this one, what remains is dv plus av. So it is d plus a operating on v. Fine. Let me differentiate again. D square e to the power axv. D square means twice. Let me differentiate it twice. Instead of this, let me explain it over here. It will be easy to explain. So you see, it is two functions. This is d square v e to the power ax as it is. Then dv as it is, derivative of e raised power ax. It is a e to the power ax plus. Okay. See, one more differentiation is d square v e to the power ax as it is. Done. Now dv as it is, derivative of e to the power ax is a e to the power ax. Again, same rule here. It is plus a e to the power ax. Derivative of v is dv. Then v and a as it is, derivative of e to the power ax. It is a e to the power ax. So it is a square e raised power ax. Fine. Again, let me explain it again. This is d square v e to the power x as it is. Now dv as it is, derivative of e raised power ax is a e to the power ax. Now here a is as it is, e to the power ax is as it is, a e raised power x. Derivative of v is dv. Now v is as it is, a is as it is, derivative of e to the power ax is a e raised power x, which is a square. What is now this? Keep e to the power x out. It is d square plus twice a dv plus a square. You see, this is d square, this is a square operating on v. This is v, this is v, this is v. I don't have to keep it here now because I have taken it out. So this is d square plus a square. This is a d e raised power x. I have taken ad. This is 2s ad. This is nothing but e to the power x d plus a whole square on v. So generally, if I have fd operating on e to the power ax into v, then this is equal to e to the power ax f of d plus a operating on v. This I have seen, this I have shown. So I will be using these things to in my further lecture. Okay, I think this is clear. If you have still some doubts and clarifications, you can ask me through WhatsApp. Huh? For yesterday's lecture, I have received just one comment that if y1 is a solution, y2 is a solution, then c1, y1, c2, y2 is also a solution. So he wants to, some student wants to ask me, are there, let me put it in this form, are there three solutions to the solution to a problem? If y1 is a solution, y2 is a solution, it will satisfy it. Why to write c1 y1 plus c2 v2? For that I have already explained that superposition principle is there. But then one more question, very important question, very good question. Only one student asked that if y1 is the solution, y2 and c1 y1 plus c2 y2 is also solution, means you have three solutions. Is it okay? A second order differential equation we have three solutions. A third order differential equation we have 4, and another order equation will have 5. I can answer you right now, but I will not answer it, because if a student can think over it, why we have two solutions and we have linear combination of that also a solution, why not other? We have around 90 students in my class and only one student had raised this question. So I want you everyone to see the books, see the this is quite easy now to find the solutions. You can go to the social media also, but then see a book where it will be written why this solution is being taken, the linear combination, what is linear dependence, what is linear independence. You will come to know if you read it. Otherwise I will also tell you, when then you will listen and you will just forget. Now let me take questions regarding what I have taught you so far. Now question number 1, d square plus 5d plus 6 operating on y equal e raised power 3x. See, right hand side is a function of x and it is first form, case 1, e to the power ax. Now what is auxiliary equation? I have to find the solution, general solution. General solution is comprising of complementary function and particular integral. You know how to find complementary function. For that you have to find auxiliary equation. What is auxiliary equation? 5m plus 6 equals 0. You have to replace, this is fd operating on y, you have to replace d by m. This will be fm equal to 0. M square 5m plus, what's m? Minus b plus minus under root of b square minus 4ac by 2a. So minus 5 plus minus 1 by 2. It is minus 2 and minus 3. So what is the complementary function? It is c1 e raised power minus 2x. C2 e raised power minus 3x. I have not written y. This is not complete y because right hand side is not 0. If right hand side would have been 0, this would have been y. Now this is only the complementary function. What is particular integral? Particular integral is e raised power 3x d square plus 5d plus 6. So what is the rule? E to the power ax upon fd, you have to replace d by a, right? What is the a? A is 3. You can put it here. It is e raised power 3x. 3 square is 9. 5 into 3 is 15 plus 6. So it is e raised power 3x divided by 15 plus 9. 24. 24 plus 6, 30. Or 15 plus 15 is 30. Now general solution is e raised power, complementary function plus particular integral. It is c1 e raised power minus 2x, c2 e raised power minus 3x plus e raised power 3x by 30. This is the solution. Why? General solution. This is the solution. You see, this can also be found in this form. You have two roots, minus 3 and minus 2. You can write the factors as d plus 2 and d plus 3. If it would have been 2 and 3, factors would have been d minus 2, d minus. You have to replace d by 3. You see, sometimes it is easy to factorize it. This is 3 plus 2 is 5. 3 plus 3 is 6. So 5, 6 are 30. You can solve it like this also, or you can put directly the value. Fine. Next one. D square plus 9 operating on y e raised power x. I will not show the complementary function, or let me show the complementary function. Auxiliary equation is m square plus 9 equal to 0. So m is plus minus 3 iota. So your alpha is 0, beta is 3. So complementary function is e to the power 0x, c1 cos 3x, c2 sine 3x. And particular integral is e raised power x d square plus 9. You have to replace d by a is 1. So e raised power x by 1 plus 9, it is e raised power x by 10. So general solution is CF plus PI. Right? Let me take one more question. D cube plus 3d square plus 3d plus 1 whole square operating on y equal to e raised power x. What is the auxiliary equation? M cube plus 3m square plus 3m plus 1 equal to 0, which is m plus 1 whole cube equal to 0. Right? M plus 1 whole cube. What's m? So m is minus 1, minus 1 and minus 1. You have 3 repeated factors. So complementary function C1 c2x c3x square e to the power minus x. Particular integral e to the power x upon this fd or d plus 1 whole cube. See, this is d plus 1 whole cube. You have m equal to minus 1, minus 1, minus 1. What you have done actually, you have replaced d by m. So m is as good as d. So d is minus 1, d is minus 1, d is minus 1. So you have three factors, d plus 1, d plus 1, d plus 1. This will be d plus 1 whole cube. So what is the solution? E to the power x, 1 plus 1 whole cube. So it is power x upon 8. So general solution is CF plus PI. Fine. Let me write same question. I have written e raised power minus x over here, not plus x. Okay. I will be showing only particular integral. Question is d cube plus 3d square plus 3d plus 1 operating on y equal e raised power minus x. So complementary function, there is no change in complementary function. Particular integral, you have e to the power minus x upon d plus 1 whole cube. You see, this is a case of failure because you have to replace d by minus 1. D by a is minus 1 over here. So this is a case of failure and r is 3. So what is the solution? E to the power minus x, x is power 3 by factorial 3. Fine. So it is x cube by 6 e to the power minus x. So general solution is same, CF plus PI. Got it? The case of failure was there. One more question. D square minus 3d plus 2 operating on y. Let me write plus. I have taken like yesterday d square minus 3d. I am taking plus 3d. And let me write it as it is power minus x minus I. It will be a case of failure. I will not be showing this. Okay. Auxiliary equation is m square plus 3m plus 2 equals 0. What is m? Minus b plus minus 1 by 2. So it is minus 1 and minus 2. So complementary function is c1 e raised power minus x, c2 e raised power minus 2x. Now particular integral is e raised power minus x d square plus 3d plus 2. Now what you have to do is that you have to replace d by minus 1. This is minus 1 square is plus 1. 3 into minus 1 is 3 plus 2. This is a case of failure. Now how to do it? I have to break it into factors. You have two factors, minus 1 and minus 2. So d plus 1 and d plus 2. You see, this is not a case of failure, but this is a case of failure. For this factor is a case of failure. So let me use both formulas. For this, what I have to do, this is 1 upon d plus 1. This is a case of failure. I have not touched it. This is e to the power minus x upon d plus 2. This is the question now. Two factors. This is a case of failure. I assume that this is not there. This is the question. E to the power ax upon fd. I have replaced d by a. So it is 1 upon d plus 1 e raised power minus x minus 1 plus 2. So it is equal to e raised power minus x upon d plus 1. Now this is a case of failure. When you replace d by minus 1, you will get a case of failure. So what is for this? What is the formula? X raised power 1 by factorial 1 e to the power minus x. This is the particular integral. So general solution is CF plus PI. Fine. Let me take one more question. D square plus 6d plus 9 operating on y equal e raised power minus 3x. Okay, this is auxiliary equation. M square plus 6m plus 9 equals 0. So m is equal to minus 3 and minus 3. Minus 6 plus minus under root of, yes, minus 3 and minus 3. Complementary function I will not write. Particular integral is e raised power minus 3x upon d plus 3 whole square. See, this is a case of failure. When we replace d by minus 3, it is 9 minus 18 plus 9. This is a case of failure. So you have written that in this form, d plus 3 whole square. You see, clearly this is a case of failure. So I will write it x square by factorial 2 e raised power minus 3x. This is particular integral. General solution is y equal to cf plus pi. Okay, now let me take up cos function. Same questions I can take. Let me take this one, and you have a cos question. See, cos of 2x. Okay. Now complementary function I will not discuss. Only I will discuss particular integral. So particular integral is cos 2x upon d square plus 60 plus 9. What is the rule? You have to replace d square by minus a square, means d square by minus 2 square, it is minus 4. It is not minus 2 whole square, it is minus a square, minus times a square. So a is 2 over here, so minus 2 square is minus 4. Let me do it. This is cos 2x minus 4 plus 60 plus 9. I cannot do anything with d right now. So this is cos 2x 60 plus 5. 60 plus 9 minus 4 is 5. Now how to get d square? Because for sine and cos I have to bring d square. What I will do is that I will rationalize this. This is 60 minus 5 upon 60 minus 5. So this is 6 differentiation of cos 2x minus 5 cos 2x. 6 36 d square minus 25. D square will not change. D square is same, minus 4. So this is 6. Okay, what is differential of cos 2x? It is minus 2i. So minus 12 sine of 2x minus 5 cos of 2x divided by, this is minus 4. Minus 4 into 6, 36. 6 4s are 144. Minus 144 minus 25. So the particular integral is 12 sine 2x plus 5 cos 2x upon 9 6 1. Minus will cancel out, minus in the numerator as well as in the denominator. Got it? This is quite simple. Next question, very simple question. D square plus 1 operating on y equals sine 2x. I will only choose pi. Sine 2x d square plus 1. See, this is not a case of failure. I have to replace d square by minus 2 square, again minus 4. So it is sine 2x minus 4 plus 1. So minus sine 2x by 3. This is the particular integral. The general solution is CF plus PI. Okay, got it? Let me take one more question. D square plus 9 operating on y equal sine 3x. Again, I will not be discussing complementary function. I will directly go to particular integral. Particular integral is sine 3x upon d square plus 9. You see, this is a case of failure, right? D square is to be replaced by minus a square. So what is the solution? For sine, it is minus times. Minus x by 2 into a. A is 3. Cos of 3x. So particular integral is minus x by 6 cos 3x. Okay? Sine ax upon d square plus a square. The solution is minus x by 2a cos of ax. This is what I have written. Another question. Say d square plus 4 operating on y equal cos 2x. Again, particular integral is cos 2x d square plus 4. You see, this is a case of failure. D square is replaced by minus 4. So case of failure. So it is x plus, cos means x plus 2a, a is 2, sine of 2x. So particular integral is x sine 2x by 4. The general solution is complementary function plus particular integral. Let me take one more question. D cube minus 6d square plus 11d minus 6 operating on y is sine x. I have shown you this question. Its roots are 1, 2 and 3. I will not go to the complementary function. Now particular integral is sine x upon d cube minus 6d square plus 11d minus 6. For sine or cos, what is the rule? You have to replace d square. So I will be having d square over here. This is d cube, which is d square into d, minus 6d square plus 11d minus 6. Now d square is to be replaced by minus a square. A is 1, so minus 1. So sine x minus 1 into d minus d square is to be replaced by minus 1. So plus 6 plus 11d minus 6. Okay? D square is to be replaced by minus 1. So minus 1 into d minus 1 minus minus plus 6. This goes. So what is this? This is sine x upon 10d. You can do two things now. You can rationalize, as I have said, d upon d square. Or this is 1 by d of sine. What is 1 by d? 1 by d is integration. So integration of sine is minus cos x by 10. See, one rule is this, sine x by 10d. I have multiplied by 10, divided by 10. Multiplied by d, divided by d. D square is to be replaced by minus 1. So differentiation of sine, it is cos x. D square is minus 1, so minus 10. Same is the case over here. This is 10, this is sine upon d. Means integration of sine, which is minus cos. Same. Okay, I hope you understand this. For sine, cos, etc. If instead of sine x, I will write sine cube. I will be writing right hand side. This question is same. I will be writing sine cube theta, sine cube x. What will you do? You don't have any direct formula for this, but you know what is sine 3 theta. It is 3 sine theta minus 4 sine cube theta. So sine cube theta, it is 3 by 4 sine theta minus 1 by 4 sine 3 theta. So if I will write this question, if this is the question, sine cube theta, this is a home assignment now. Question is sine cube theta. Same question. Instead of sine, you have sine cube. This will be, right hand side will be 3 by 4 sine x minus 1 by 4 sine 3x. So for this you will have a separate particular integral. For this you will have separate particular integral. Because for this you have to replace d square by minus 1. For this you have to replace d square by minus 3 square. Which is that? Which is minus 9. Okay? You will do it, huh? Let me write one more question. Or this is okay. Let me not go deep into this. Let me have one more question. D square minus 4d plus 4 operating on y equal e raised power x plus cos x. Okay, you have two functions now. This is e raised power x and cos x. This is nothing but d minus 2 whole square operating on y equal e raised power x plus cos x. I will not go to the complementary function. I will go to particular integral only. E raised power x d minus 2 square, then cos x d minus 2 square. This is quite easy now. You have to replace d by minus 1, sorry, d by a. This is 1 minus 2, so it is e raised power x only. Cos, you have to replace d square. I don't have d square, so you have d square minus 4d plus 4. D square is to be replaced by minus 1. E raised power x cos x minus 1 minus 4d plus 4. So e raised power x cos x 3 minus 4d. Now you have to rationalize it. Okay. This is 3. 4 minus 1 is 3. 3 minus 4d. You can write it as e to the power x cos x. Okay. 3 plus 4d cos x. 3 minus 4d, 3 plus 4d, it is 3, 3, 9 minus 16d square. Now d square is to be replaced by minus 1. So particular integral is e raised power x 3 cos x minus 4 sin x by 25. D square is minus 1 minus 16 plus. Okay, fine. Now, if I will write one more thing over here, plus e raised power 2x, this will be a case of failure. This is home assignment. You see, if I will write, this is quite easy question. I will be forwarding you some more questions. This is this is very easy question. E raised power 2x upon t minus 2 whole square. See, one more particular integral will be here. 2x g minus 2 whole square. This is a case of failure. You have to multiply by x square by 2 factorial. Fine. Okay. Now let me come to the polynomials. D square minus 3d plus 2 operating on y equal to 1 plus x. This is a polynomial in x. What I will do, complementary function, leave that. Particular integral x plus 1 d square minus 3d plus 2. What I have said, what I have written is that you have to take lowest degree term out of this ft. This is x plus 1 2 times 1 plus d square minus 3d by 2. Okay, this is 1 plus minus some function of d. This is capital FD. Now I have to take it to the numerator 1 by 2. 1 plus d square minus 3d plus 2 whole raised power minus 1 operating on x plus 1. You see, x plus 1. How many times you will differentiate it to the maximum? X plus 1 means differentiation first time will be 1, second time it will go. So you have to take d only. D square will be 0, dq will be 0. So what is this? This is 1 by 2. Now 1 plus x raised power minus 1. What is that? 1 minus x plus x square minus x cube plus so on. So I will use that formula. This is 1 minus x, x is d square minus 3d by 2. Plus it is square, d square minus 3d by 2 whole square plus minus so on operating on x plus 1. So this is 1 by 2 x plus 1, then minus, see, this will not give us anything. I will just get minus minus plus 3 by 2 differentiation of x plus 1. The rest will be 0 because you can differentiate x plus 1 maximum 1 times, second time it will be 0. So what is the solution? 1 by 2 x plus 1 plus 3 by 2. Or you can simplify it, 2x plus 5 by 4. This is it. 2x plus 2 plus 3 is 5 divided by 2 into 2, 4. This is the particular integral. General solution is complementary function plus particular integral. I will conclude with one example. Two d square plus 5d plus 2 operating on y equal to 2x plus 5. Okay. Now, what is the auxiliary equation? I will write. Or I have, okay, auxiliary equation is 2m square plus 5m plus 2 equals 0, which gives m equal minus b plus minus 25 minus 16, which is 9, which is 3 by 2, which is minus 2 and minus half. Complementary function c1 e raised power minus 2x, c2 e raised power minus 1 half x. This is the complementary function. Remember yesterday's last question. This is the same question. Why I had taken x, y equal x as a solution. I will be showing that this x is actually the actual solution, actual particular integral. Now particular integral. Pi 2x plus 5 upon 2d square plus 5d plus 2. This is 2x plus 5, 2 times 1 plus 2d square plus 5d by 2. Okay. I have taken the lowest degree term out of this fd. This is 2, rest is 1 plus some function of d, 2d square plus 5d. Now take it to the numerator. This is 1 by 2, 1 plus 2d square plus 5d by 2 raised power minus 1 operating on 2x plus 5. Now let me use the formula 1 plus x raised power minus 1. 1 by 2, 1 minus 2d square plus 5d by 2, then 2d square plus 5d by 2 whole square plus so on operating on 2x plus 5. You see again 2x plus 5, you can differentiate it only once, second derivative will be 0. So I will conclude this is 1 half 2x plus 5 minus 5 by 2 differentiation of 2x plus 5. Now what is that? This is 1 half 2x plus 5 minus 5 by 2, and this is derivative is 2 only. 2x plus 5 derivative is 2. So what is it? This is 5 minus 5. So 1 by 2 2x plus 5 minus 5. 1 by 2 into 2x, it is x. So exactly the particular integral is x. So general solution is CF plus PI. This is it. So let me conclude it here. Thank you. Thank you very much.